So we started this on Friday, but we did not finish. And what we wanted to do is we wanted to implement first derivative test and second derivative test. So the first derivative is we had x squared minus 4, and we set it equal to 0, and we got x plus 2 and x minus 2. So as we made our number line, we marked off -2 and +2. And f double prime of x was equal to just 2x, correct? Did we do the second derivative piece on Friday? Okay, where's the second derivative equal to 0? Where is this derivative equal to 0? At 0. So now we have our testing points. So what I will do now is I will test numbers between negative infinity, -2, -2 to 2, and 2 to infinity. What would be a number to the left of -2 you want to plug in? And as I plug in -3, I get a negative times a negative is a positive. And then what is the number between -2 and 2 I can plug in? 0. If I plug in 0, I get positive times a negative is a negative. And then if I plug in, say, +3, I get a positive times a positive is a positive. For the second derivative, what is a number to the left of 0 you can plug in? -1, and you get a negative, and to the right of 0, you get a positive. So this will allow us to tell intervals of concavity, intervals of increasing and decreasing. This one tells us increasing and decreasing. This tells us concavity. Yep. Increasing was, we already did that on Friday. So from -infinity to -2, union with 2 to infinity, and then decreasing from -2 to 2. And do not include the -2 and 2 because it's not, the derivative is 0. In order for it to be increasing, the derivative must be positive, so we don't include that. We can also talk about concavity. Concave up and concave down. Where's it concave up? Where the second derivative is, wherever the second derivative is positive. The second derivative is positive from 0 to infinity. Second derivative is negative from -infinity to 0. Also, I want to identify local max, local min, as well as points of inflection. There are two interesting pieces about the local max and local min. Number one, the local max happens where the derivative changes from positive to negative. Now, let's think about that. If I have a local max, the derivative is changing from positive to negative. It is also concave down. So let's look. Changes from positive to negative, and is the graph concave down in that region? Yeah, see how I line up my intervals so I can see that that matches? So it is concave down when it crosses from positive to negative for the first derivative. So yes, we have ensured that there is a local maximum that happens at -2. How do I find the y value? You plug it in. Did we do that on Friday? Okay, so we can go to our calculator just to save time here. We got 1/3 x to the third is it -4x plus 2? Nope. And then I plug in -2. I get a 7.33. And for the min, I plug in, where does the minimum occur? And at 2, if there's a minimum, should a minimum be concave up or concave down? And you can see that I'm concave up where the first derivative changes from decreasing to increasing. So that confirms our work. So we know at 2, if I plug in 2, you get -3.33. Where's the point of inflection? Where the second derivative changes sign, right. So if I change from negative to positive, I have an inflection point at 0. If you plug in 0, you get 2. So those are the all-important characteristics and aspects of that graph. That's what you want to do for your assignment today. What do you think? Not too bad? Well, yes. So we're gonna. For our first two examples, we're gonna do this. Our second two examples, we'll actually sketch a graph at the end. And you'll see how accurate our graph is. Okay. So we move to our next one. We're gonna do letter B. Again, I'm gonna use extra paper because I did not give you guys enough. My bad. So f of x is equal to negative x to the fourth plus 2x squared. I need to find both derivatives. First derivative, f prime of x is I'll factor and set it equal to 0. What can I factor out? I get a 4x, and I get an x squared minus 1, or negative 4x times x plus 1 times x minus 1. What is the second derivative? We'll do in a second. Negative 12x squared plus 4. I could factor out a negative 4, and I would get 3x squared minus 1. So, as Hannah said, let's solve it and see where it's equal to 0. Where's the first derivative equal to 0? Second derivative, where's that equal to 0? Very good. The square root of 1/3. Does everybody see that? So if you were to solve the square root of 1/3, you would end up writing it as plus or minus the root of 3 over 3. That's how you would simplify the square root of 1/3. We want to rationalize the denominator. We say that pretty quickly. We used to spend a couple days practicing those type of things. So, what? You have a booger? Okay. Well, you're laughing at me and looking at me like I did. Okay, fine. All right, I mark them. And I like to try to line up my derivatives, my number lines, so that they match. So the square root of 3 over 3 is about 0.57. As I mark this out, 0, negative 1, positive 1, negative root of 3 over 3, and positive root of 3 over 3. That way I can, they just line up better if I do that. So what value should we plug in first? Negative 1. Negative 4 times negative 1 is a... No, I can't plug in negative 1. Top one, not the bottom one. Negative 2, thank you. So we get a positive times a negative times a negative. Positive. Now what number? Negative 0.5. Negative times a positive times a negative. Yeah, first one should be negative, right? First one, if you plug in negative 2, we get a positive times a negative times a negative. Was it? So that's, yeah, that is positive. Oh. Positive times a negative. That would be now we plug in 0.5 would be a negative times a positive times a negative. Now I plug in 2 negative times a positive times a... They don't always switch sign. We'll look at an example where it doesn't later. Okay, what do I plug in here? Negative 1. And you don't have to factor this out. Just plug in -1. -1 squared is 1 times 3 is 3 minus 1. That's a positive times a negative is a negative. What's an easy number to plug in now? 0 minus 1 will be negative. -4 is negative, so that'll be positive. Plug in +1, and you'll get a positive times a negative is a negative. Intervals of increasing. Decreasing. First derivative. No, increasing, decreasing are determined by the first derivative. Decreasing, -1 to 0, union with 1 to infinity. Concave up. -√3/3 to √3/3. Concave down from negative infinity to -√3/3. Union with √3/3 to infinity. Local max should happen where the first derivative, what? Positive to negative. So -1 and at 1. Furthermore, a local max should happen where it's concave, what? Concave down. So let's look at those spots, okay? If I draw this all the way through, and I consider that -1 and that +1 spot, are the graphs concave down there? At -1, am I concave up or concave down? Concave down, because the second derivative is negative, so therefore I'm concave down. Here, I'm also concave down. Okay? So therefore we know we have local maxes at -1 and +1. We change from increasing to decreasing, increasing to decreasing, and we are concave down. That confirms that we have a local maximum. I plug in -1 and 1 to which? Where do I plug that in? Into the original. We plug in -1, we get -1 plus 2 is 1. If you plug in 1, we also get 1. You plug it into the original, -x to the 4th plus 2x squared. The minimum occurs when the first derivative changes from negative to positive. So it looks like at 0, the first derivative changes from negative to positive. At a local minimum, am I concave up or concave down? Concave up. And you can see you are concave up at 0. So we have a local minimum at 0. Plug in 0 and you get 0. The only piece I'm missing is inflection. The inflection point occurs when the second derivative, what? Changes sign. And that happens at -√3/3 and +√3/3. So I will take those and I will plug them in. -x to the 4th plus 2x to the, what was it? 2x squared, okay. And if I go to my table and I type in -√3 divided by 3, I get 0.56. And if you do it again, √3 divided by 3, Again, you also get 0.56. So we have used the first derivative test and the second derivative test in order to determine increasing, decreasing, concave up, concave down, max, min, and points of inflection. Okay. What I would like you guys to do right now is on your own, I would like you to try example C. That's labeled B, my bad. But if you look at this one right here, x to the third minus 6x, and you can use that space where letter E is. We're not going to do that example. 4 will be enough for this assignment. You can go ahead and go there. So we'll go ahead and take some time to do C. That'll take us up until lunch, and then we'll finish up when we get back from lunch. Okay, so I forgot to record a little bit there. You can look and see what we've got for intervals of increasing, decreasing, and concavity, max, min, and inflection. We also sketched a graph. You can do that on a calculator. So we go to D. First derivative. F prime of x is 4x to the third plus 6x squared. Factor out a 2x squared, and I get 2x plus 3. Second derivative. 12x squared plus 12x. Factor out 12x. Okay, make a number line. Where is the first derivative equal to 0? And negative 3/2. Good. Where is the second derivative equal to 0? Okay. So I'm going to plot these points. 0, negative 1, 0, negative 3/2. As I plug in values, true or false? 2x squared is always positive. True. So I don't even need to worry about this front part, do I? The front part's always positive, so let's just look at the inside. We plug in negative 2, I get a negative. Plug in negative 1, I get a, because it's always positive. And positive doesn't affect the sign change. Only negatives affect sign change. So plug in negative 1, you get positive. Plug in positive 2, and you get positive. What do you notice? It didn't change sign. You can't always count on changing sign. Okay, now we check down here. Negative 2, I get a negative times a negative is, plug in negative 0.5, and I get a negative times a positive, and then plug in 1, positive times a positive is positive. So just a basic testing like that. I can now list increasing and decreasing. Where is it increasing? Negative 3 over 2 to 0, and then from 0 to infinity. You can't include 0 because it's not increasing or decreasing at 0. Decreasing from negative infinity to negative 3/2. Because the definition for increasing is where the derivative is positive. And at 0, the derivative is 0. And that's neither positive nor negative. It's the absence value. So we have concave up. We have concave down. Where is it concave up? Good. Negative infinity and negative 1 union with 0 to infinity. And it's concave down from negative 1 to 0. Max and min. Where is it going to have a maximum? Where it changes from positive to negative, right? Does it ever change? First derivative ever change from positive to negative? So there is no maximum. The maximum occurs where the first derivative changes from positive to negative, and it never changes from positive to negative. So therefore, there's no maximum. The minimum occurs where it changes from negative to positive. Does that happen? At negative 3 over 2. And if you plug in negative 3 over 2, you can see that it is concave up there, so it is a minimum. Let's go to our original function. I'm going to run out of time here if we're not careful. What do we have? X to the fourth? Negative 1.69 we're going to roll with. And then we have our inflection point. True or false? I have more than one inflection point. True. Inflection occurs where the second derivative changes sign. So that's going to happen at negative 1 and at 0. If you plug in 0, you get 0. If you plug in negative 1, we get 2 or 1. If we plug in negative 1 fourth is 1. No, you're right. Okay, negative 1. There you go. Okay, so I'm going to graph it in a second, but first I'm going to sketch a graph on my own. Let's look at the original function. What's the y-intercept of the original function? And if I wanted to find the x-intercept, I would factor out an x to the third, and I get x plus 2. So what are the x-intercepts for the original function? Negative 2 and 0. So I have an x-intercept of negative 2, I have an x-intercept of 0, and a y-intercept of 0. I also have, do I have any maximum values? Do I have a minimum value? Where does it occur? Negative 3 halves and, okay, so negative 1.5 and negative 1.69, right about there. I just have that one local min. What are my 2 points of inflection? 0, 0, and, right. Does the graph start by decreasing, or does the graph start by increasing? Decreasing. So I start up here. I'm decreasing. So you can see concave up, concave down, concave up, decreasing, increasing, increasing. Matches with what we have listed. And if we check within our window, negative 3 to positive 3, and then we will go negative 2 to positive 2, a tick mark every one. I sketch the graph. Pretty good, huh? I mean, to think that we can sketch it that accurately within 5 minutes, pretty impressive. We're going to be spending a lot of time on this unit. That's kind of your first introduction. That is not your assignment. Your assignment is going to be 4.3, page 247, 11 through 13, 3 problems you don't make a graph, and then 3 problems where you do make a graph. You'll be doing the first and second derivative tests just like we've been doing. I think you guys will do very well on this test, by the way.